Hi everyone, my name is Josephine Hartman and my partner's name is Blake Coulter. Our topic for this presentation is based around the visual recognition of various fish species done through the utilization of neural networks. So for a brief overview and recap of visual recognition. So in the machine learning context, it's the ability for software to somewhat understand and classify images that are given. Visual recognition, or also known as image recognition, is done because it benefits data configuration and it's highly useful and applicable to many real-world scenarios and situations, such as population estimates and very specifically overfishing, which is what we're going to see here in a bit. With its efficacy, you may now wonder how visual recognition can be achieved. Well, just like the subject of the class, visual recognition can be done through different machine learning algorithms like neural networks or k-means. So in context to this specific project, visual recognition was used to categorize multiple fish species through the use of neural networks. So the overarching goal of this project is to categorize fish by their species type. This discernment and classification can help count fish by their species type, which in turn can aid in real-world scenarios such as determining population estimates, determining if the catch limit is being reached, which plays a great role in overfishing, and determining ecological stability. The dataset used consists of numerous images of many different fish species. The fish species in question used include black sea sprat, githead bream, horse mackerel, red mullet, red sea bream, sea bass, shrimp, striped red mullet, as well as trout. Each species type contains around 1,000 images of the fish from multiple angles. The amount of angles that are used gives the algorithm a better sense of what type of fish can be categorized as which species. So here is a little picture of the dataset. So here there are only a couple images as to what the dataset looks like. As you can see, there is only one image per species, but don't worry, this is only a very small snapshot compared to what was actually used in our program. So cumulatively speaking, there were approximately 9,000 images combined of all the different species of fish.
Hi, I'm Blake, and I'll be discussing our neural network implementation. We plan to train a neural network by feeding in images of fish to a TensorFlow CNN, using multiple species of fish, as seen previously, in various orientations. A CNN, aka a convolutional neural network, works by using a kernel, or feature filter, and running it over an image to identify objects within the image. CNNs, however, are prone to overfitting, which we plan to keep an eye on through the rest of the project. As for the results, accuracy on the validation data over 10 epochs went from 0.57 to 0.62, or from 57% to 62%. These results were performed on a sample of the full set of data, as attempting to run the full set of data is causing TensorOverflow to allocate too much RAM and crash. In the future, we plan to run the algorithm over the entire set of data and tweak the parameters of the kernel in order to increase the accuracy.
So here are our references. The first reference is where our dataset was from, and the next two references are just supplemental in terms of more information about visual recognition as well as neural network application. Thank you.